All right, so the project for tonight is taking this uh, wireless charging dock, and I don't know if you saw the other videos, but sometimes when you drop this in, when it's flying and drops in, it lands in, and then sometimes it misses. And I've missed enough times here where I thought, man, it'd be nice if you could just take this rim and you could just widen it, and if you shape it the right way, it should just direct a higher percentage of the drone landings in. And so I that's been my project for tonight, and I set out doing that. So I can just kind of go through what I did here. But I started out kind of taking some measurements of things, and there's actually a kind of a cool uh, charging design of the dock. So you see these two rings. I would guess they're copper. I'm not exactly sure. They kind of look like copper, I guess. But these two rings connect to two sets of nodes on the bottom here for charging. So if you look carefully here, these little, I'm just gonna call them pins, the little pins that come down. They're either on the outside ring or the inside ring. So this one is on the outside ring. You can see the line. You can see the line right there. And this one's on the inside ring. And then the other two, if you rotate it, this one's on the outside, it looks like, and you see the line. And this one's on the inside. So at any point, when the drone lands here, at least one should be touching the outside, one should be touching the inside, and from those two, from the differential there, you can charge the drone, and you don't have to plug it in or anything, and so this wireless charging, in a sense, is really what enables the autonomous operations, not need a human to plug in the drone, because it maybe has, I don't know, 3 or 4 minutes of lifetime, but if after that it can go land on its dock, it can monitor its recharging and then take off on its next mission. That really enables the autonomy and really increases the usability and utilization of the drones. That'll be real nice. So my goal is to improve this little dock you see here, by taking this bit and extending it out more, and so that's been my project for the last few hours here. And I actually picked up a 3D printer about a month ago, and that's been super useful. So this base hunk of plastic is a 3D printer. You can kind of tell if you look closely at it. Here's a shot of the drone. Oh, and then here you can see the pins. So this is ground here. This one's ground, G&D. This one's ground, and then I'm not exactly sure what this stands for, but VUSB, I think, VUSB. And you can kind of see, but the VUSB is right up under BL. So this CF 2.1 is Crazy Fly 2.1, BL is brushless, and then you have the little pin or the node right under that for the V USBs, and these are farther out on the arm. They're on the outside track, and the grounds must be the inside track then, because you can see they're quite a bit farther below the BL there, so they're on the inside track. But so what I did, I took the measurements, and my initial thought, just a very early thought, was, I can make kind of a base, and then have this sit on the base, and this could rise up, and then just help funnel the drones in. And so I took some measurements, dimensions. I went to Claude, and Claude these days, you can just give it some points, and it will be able to mock this up, which is really cool. So that was my initial design, and then I changed it up a bit, into instead of having like this whole setup here, what I did is, like, I just observed that, like, actually you only really need this bit here, and then you need some way to kind of position this bit at the right spot, and so I kind of made a little cutout shape where it's like this bit, and then there's a little notch there to rest on the inside of here, and then just this other bit, and so that turned into a ring of plastic, like this. So this was kind of my first measurement, was just something like this, and so the way I could set that up is I gave it 5 points here, and so I defined this 5-point shape, and on like a standard kind of XYZ coordinate plane, and I said, okay, take this 5-point shape, rotate it 360 degrees about the y-axis, and that will give you the ring. And that was enough for Claude, that Claude could come up with this .stl file, which is used in 3D printing. And yeah, so that was the shape. And I've iterated, I think 3 or 4 or 5 times on that. But I made it a little wider here, and this was kind of the first one I was pleased with. So this one was this is my kind of first one I printed out, and it was a little too wide, and which is to be expected on the first one. You know, it's not going to be perfect. And the second one is better. It's strong enough to sit on there. So you can imagine you're taking a drone, and if it lands a bit farther out, it still can funnel down. And there are reasons you can't just make it infinitely wide. And I could kind of go over here, but essentially what you need the constraint is this bottom clip that has to come on the inside, so it falls in. But as the drone is falling, the left clip there has to be on the inside, but the right one also has to clear. It has to clear that bit there that you can see. So if you get caught inside, even something like that, you know, something like that might not work. The left is inside, but the right is caught on the inside. So it has to be able to clear that and fall enough down. And then you also need to watch. It's gonna be a little hard to show here. Try to find something to point. Got my handy screwdriver here. Okay. And then you also have to make sure that with the prop guards on, you can see that the prop guards are what's making contact here and preventing the drone from going lower on both sides there. But you have to make sure that these points right here, the little contact pads, are able to touch that. And so that's what my 4th or 5th design is iterating on here. Is it takes the rim down a bit, and so these guards will touch at a lower point, and so these the contact pads will be able to touch still. So I think the print is finished. I'm gonna check it out here, but yeah, I'm super excited about this. In a way, it's almost kind of like my first semi-useful invention that I can make. It's very minor, but I think I was pleased that just with, you know, a passive design here of adding a chunk of plastic to this, it makes it a lot more useful and increases the efficacy of the landing on the charging pad. So we'll see. I think I was about 20 or 25% of the landings were successful the other day when I was trying. So I'm gonna try to improve this here and see if I can get that number way up. So close to 100 hopefully. So yeah, I'll post this and finish up the work here and post something later too.